All right, let's jump right into today's explainer because we're looking at a truly fascinating piece of research. We're going to see how AI is learning to literally strip away the visual illusions created by our cameras to uncover the pure mathematical truth underneath. It's a incredibly elegant solution to a problem that has been completely baffling computer vision systems for years.
To really grasp why this matters, we have to start with a massive real-world problem. How do we safely train self-driving cars? We obviously can't just throw millions of experimental cars onto real city streets and just hope for the best, right? To train them effectively, we need perfect virtual worlds. We need digital replicas of our cities that are entirely indistinguishable from reality. And that brings up a super interesting hurdle. How exactly do you build a perfect, persistent 3D world from simple, flat 2D photos? Well, to build these digital environments, scientists rely on a really groundbreaking technology called NeRFs, which stands for Neural Radiance Fields. Basically, you feed an AI thousands of everyday photos of a scene, say a bustling city street or even just your living room, and the AI studies them. It learns the geometry, the depth, and the lighting of the world from those flat images so well that it can synthesize completely new, fully 3D views. It literally generates the empty spaces in between the photos. It sounds brilliant in theory, but researchers have been running into a major roadblock in practice. Because instead of producing these perfect, pristine 3D models of our world, the AI was churning out glitchy, ghostly floaters. You'd load up the virtual environment, and there would be these bizarre artifacts just hovering in midair, blurring the whole scene and completely ruining the simulation. And if you're trying to train a self-driving car where life and death are on the line, a blurry, artifact-filled nightmare world is absolutely useless. The algorithm was clearly getting confused, but the question was, by what? Let me give you a quick analogy to picture what's confusing the AI here. Imagine you're in the market to buy a house. You go check it out on Monday, and the house is painted blue. You go back to check it again on Tuesday, and suddenly the house is fiery red. Then you drop by on Wednesday, and it looks totally dark and shadowy. You'd be incredibly confused. Did the house magically change its paint job overnight? No, obviously not. The realization here is the key to this whole puzzle. As the researchers framed it, it's not magic, it's just a normal house, but each day you showed up with a different pair of sunglasses. And this is exactly what happens with our cameras. Cameras are constantly changing their own digital sunglasses. Based on how much light hits the sensor at any given millisecond, a camera is automatically adjusting its exposure and white balance from one frame to the very next. So think about what happens when you feed thousands of those ever-changing photos to an AI. When the AI tries to stitch them together into a 3D model, it runs headfirst into a disastrous camera bias. Because the camera altered its internal parameters from shot to shot, the AI mistakenly assumes the physical objects in the real world actually changed color. It literally thinks the house turned from blue to red. As a result, the AI takes those automatic lighting adjustments and bakes them directly onto the 3D objects as physical colors. And that is exactly what creates that blurry, unusable 3D model full of ghostly floaters we just talked about. Enter NVIDIA's new PPISP technique. Think of this as the master detective of our story. Instead of intensely analyzing the physical scene like all the previous methods did, this AI cleverly shifts its entire focus to investigate the camera's lenses. It looks at the photos and basically realizes, the device that took this photo was standing in a dark spot and compensated with blue-tinted settings. It investigates the sunglasses, not the house. And the mathematical tool it uses to crack the case is called a color correction matrix. Now, I know that sounds super complex, but it's really just a 3x3 mathematical grid. Think of this grid as the exact prescription for the camera's sunglasses. By solving for this specific prescription, the AI can surgically remove the blue tint and the artificial brightness caused by the camera hardware, pulling the colors in the photo all the way back to unvarnished reality. It's honestly incredible when you think about it. They have essentially reverse engineered a digital camera's entire auto exposure brain and embedded it inside a neural network. By doing this, they can generate new 3D views where you are seeing the true objective reality of the scene, completely free from the flashing, inconsistent frames that always happen when camera settings bounce around. Now, the way the AI actually peels back these layers of reality is by breaking the problem down into 4 distinct mathematical puzzles. It's not just guessing. It's mathematically deconstructing the image step by step. First, it calculates the exposure offset to undo exactly how artificially bright or dark the camera made the scene. Second, it isolates the white balance, which removes the overall color tint of those digital sunglasses. But it's really the last 2 puzzles where this tech makes a massive leap. Take puzzle number 3, for example, addressing the vignetting effect. Real camera lenses aren't perfect. They have physical flaws that naturally make an image slightly darker right near the outer edges. And just by analyzing flat photos, this AI actually learns the physical structural flaws of the exact camera lens that took the picture. It reverse engineers the physical glass of the lens and mathematically compensates for those darkening edges. And then finally, it tackles the fourth puzzle, the camera response curve. Digital sensors just don't capture light perfectly. They distort it in a very weird, non-linear way. The AI mathematically figures out that exact distortion curve for the sensor and flattens it out entirely. By stripping away all these hardware flaws through pure math, the AI can finally generate the pristine, artifact-free 3D data that self-driving cars desperately need to train safely. They finally get a perfect, persistent virtual world to navigate. But here's the catch. Even our master detective AI has a weakness. There is one device that still manages to completely confuse it, and it is probably sitting in your pocket right now. The researchers noted that this technique still really struggles with the sneaky, rule-breaking tricks of modern smartphone cameras.
You see, NVIDIA's AI operates on the assumption that a camera follows strict global physical equations across an entire image. But our modern smartphones use something called local tone mapping. These are highly advanced, spatially adaptive tricks where your phone's software might artificially boost the brightness of just your face while simultaneously darkening a bright window directly behind you. These tricks break the global rules of lighting. So when the AI sees this, its physical equations are just completely thrown out the window. It mathematically knows the whole room should be bright, not just the window. And this localized manipulation leaves the model totally confused.
But looking past self-driving cars and camera sensors for a second, the researchers' struggle with these localized camera biases actually leaves us with a fascinating philosophical parallel. The entire premise of this AI is to separate an object's true, objective color from the biased image created by the camera. And it turns out that is phenomenal life advice.
It beautifully mirrors our own human experience. Separate facts from your feelings. Don't confuse a bad mood with a bad life. Just as the AI literally has to mathematically learn and strip away the physical flaws of the camera lens to correct the final image, we have to do the exact same thing with our minds. We have to actively acknowledge our own cognitive flaws and emotional biases if we ever really hope to understand objective reality.
Because acknowledging our flaws is truly the only way to see the world clearly. Which leaves us with a pretty fascinating question to end our explainer today. If an AI can mathematically calculate and remove the hidden biases of its own hardware, how can we do the same? What colored sunglasses are distorting your view of reality right now? And what is your personal color correction matrix to find the truth? Think about that for a bit, and I'll catch you in the next one.